Okay, let's go ahead and take a look at a more challenging question for a least common multiple as opposed to the questions we just did in the previous video.
Now let's take a look at a harder question, a kind of question that can easily appear on the GRE math section. Now this involves really for you to understand least common multiple. Remember, the foundations are easy. Yes, it's easy to understand and grasp least common multiple, greatest common factor, all these different things, PEMDAS, fractions, whatever we go through in these videos seems simple, but you really have to know how to apply these basics concepts. And this is a prime example over here of what I mean. Now let's go ahead and take a look at this question over here. Let's just say that the least common multiple of 36 and x is 72. What are the possible values of x? What are the possible values of x? I would definitely encourage you to pause this video and try to do it yourself in your notebook. The least common multiple of 36 and x is 72. What are the possible values of x? Right off the back, it seems like, whoa, what's going on over here? I'm not used to this kind of question. We just went over easy questions. This isn't fair. Well, it is fair. Think about it. You can go ahead and apply the concepts that you've learned. Let's see how to approach this problem. Well, the least common multiple of 36 and the least common multiple of x is going to be 72. I'm kind of working backwards over here. Well, okay, let's see. Let's go ahead and see what the prime factors of 36 are. Well, the prime factors of 36 are, well, 6 times 6 is 36, 3 times 2 is 6, and 3 times 2 is 6. So I can go ahead and circle this, which is nice over here. So over here for 36, my prime factors are 2 to the second power times 3 to the second power. For x, I have no idea. So I don't have any idea, so I can't really work with that. Well, I do know that the least common multiple of 36 and x is 72. Let's go ahead and find out the prime factors of 72. So let's go ahead and divide the screen. 72. Well, what times what gives us 72? 9 times 8 is 72. 9 times 8 is 72. This 8 can be further broken down to 4 times 2. This 4 over here can be broken down to 2 times 2 over here. Let's go ahead and circle all our prime numbers. This 9 over here can be broken down to 3 times 3, and there we go. I have a 3 here, I have a 3 here. Okay, so now 72 is represented by 2 to the third power times 3 to the second power. This is where your fundamental knowledge, if you really know it and if you really know how to apply the basics of least common multiple, you should be able to solve this problem. Think to yourself, here I have the prime numbers for 36. Here I have the prime numbers for 72, which happens to actually be the least common multiple of 36 and this variable over here, x. Think back to the rule. The rule is that you have to take every number in its set the greatest number of time it appears. So over here, I have 3 to the second, right? And my number 36 actually happens to appear 3 to the second times, which is great. What does that tell you about x? Can x possibly, so let's just say x, can it possibly have 3 to the third power? Of course not, because if it had 3 to the third power, we would actually have this as 3 to the third power. That's not possible. You can't have 3 to the third power. At most, this x could have been represented by 3 to the second power. It could also be 3 to the 1 power. Why? Well, this simply has 3 over here, and this has 3 to the second power. This 3 appears twice, so once again, we include it over here. We can also have it appear 3 to the 0 power, which is just a 1 or nothing. It doesn't matter. It doesn't appear here at all. Instead of 3 to the 0 power, I'll make it less confusing. I'll just say it doesn't exist. There is no 3 basically, and that's also a possibility. Because remember, we have to include every single prime number the most number of times it appears. So for this over here, it could be possibly 3 to the second, or 3 to the 1, or even 3 to the 0, or just times 1 over here. How about for this side? Well, over here, for my 70, it shows that it's 2 to the third power. Over here, I see that it's 2 to the second power. Well, I have to. There's no way. It's impossible. I have to have that x over here, one of the prime numbers is 2 to the third power, because 2 to the third appears over here, and 2 to the 36 clearly doesn't have 2 to the third. It has 2 to the second, and that means that I have to have this at 2 to the third, since 72, my number, has 2 to the third. So what do we know? We know that x has to be 2 to the third times, now we have different options. We have 3 to the second, or we have 3 to the first, or we have just times 1, and that's the different possibilities. But I know that I have to have 2 to the third, because my 72 over here, when I do the prime factorization tree chart, I have 2 to the third power. So I have different options here. Remember, what are the possible values of x? Right? It's just not one possible value. It's several possible values. In this case, we have in this case, we have 3 possible values over here. I can have 2 to the third times 3 to the second. So I can have, actually, let me make this smaller so I can show more work over here. So what are my possible things that x can be? Well, x can be, well, let's put x is equal to 2 to the third times 3 to the second power. X can also be equal to 2 to the third times 3 to the first power. X can also be equal to 2 to the third times 3 to the 0 power, which is essentially just 1. Anything to the 0 power is just 1. And now let's just solve it. 2 to the third, well, 2 times 2 is 4. 4 times 2 is 8. 8 times 3 to the second power is going to be 9. 9 times 8 is 72. Okay, that's one possible value of x. How about the second possible value of x? I have 2 to the third power. 2 times 2 is 4. 4 times 2 is 8. 3 times 1 is 3. 8 times 3 is 24. That's another possible value of x. How about the third one? Sorry, the third one is going to be 2 to the third, which is going to be 8 times 3 to the 0 power, which is just 1. 8 times 1 is 8. And these are the possible values of x. This is my answer. Now, if you're, I hope you're not confused. If you are confused, please rewatch this entire question over here, and you should be able to get it. But just in case you're like, I'm still confused. I mean, I see where you're going at. Well, you can always double check your work, right? Now we can even work. Now we can go ahead and work completely backwards and say, hey, well, okay, it's saying that the least common multiple of 36 and x. Okay, we can just take any one of these numbers. Let's just say 72 over here. So let's just say 36 and 72. I know my answer should be 72. Let's go ahead and double check. I don't recommend you do this because, once again, this test is a time-sensitive test. You really don't want to spend your time plugging in and double-checking that the answer is correct. I mean, you should definitely do that, but once again, time is very important. If you know this way, you already know you're correct. If you're not sure, you want to double-check, sure, by all means, go ahead. 6 times 6, this is 3 to the second, this is 3 times 2, 3 times 2. This 72 will break down to, well, we already have it over here. 72 breaks down into 2 to the third and 3 to the second. So 36, I have 2 to the second times 3 to the second. And for 72, I have 2 to the third times 3 to the second. My rule states that I have to take each number, the greatest number of times it appears. 2 appears two times here. 2 appears 3 times here. So I have to take 2 3 times. Instead of writing 2 times 2 times 2, I can just write 2 to the third power times 3 to the second appears twice here, appears twice here. Okay, fantastic. So 3 appears twice here. And now 2 to the third times 3 to the second, if you work that out, it becomes 72. So that is correct. Now you can go ahead and plug in 24, 36 and 24. You'll see that the least common multiple is 72. You could also go ahead and do that for the number 8. And once again, you'll find that the least common multiple is 72. And there you go. As you can see, this question over here requires you to, once again, know the foundation and basic understanding of least common multiple, but you have to be able to apply it correctly.
Okay guys, don't worry, video is almost over. Now on the exam, they may ask you straightforward what the LCM of two numbers are, but more than often, they like to integrate that into some nice word problem or make it a little bit more complex. There are different ways of saying the least common multiple or finding the least common multiple, and you have to know when they're asking you to find the least common multiple. So for example, what if I said, x is the LCM of 5 and 12. That's the same exact thing as saying, find the least common multiple of 5 and 12. What if I told you that x is the lowest number, and 5 and 12 are its factors? That's the same exact thing as saying, what is the LCM of 5 and 12? What if I told you that x is the lowest number which is divisible? by 5 and 12. It's the same exact thing as saying find the ultimate LCM of 5 and 12. So once again, there are various ways they can ask you to find the LCM. Just don't be caught up with those three words. Remember, you have to get familiar and you have to be comfortable with the different wordings that they can throw at you, and you have to be able to say right away, whoa, okay, here's a word problem. I'm given this information and I can see that I have to find the LCM, or I have to find the GCF, which we'll be covering in the next video. So be aware and start practicing and learn how to apply these fundamental concepts and information. If you're still not understanding a concept or a particular concept in this video, please feel free to use our free support system at Argo Prep. See you in the next video.